Welcome to this lecture. Today we are going to deal with these topics little quickly but in detailed approach. My name is Gunjan Subedi and as always I'll be guiding you in this topic with practical explanation and examples when necessary. Before starting, let me kindly remind you to subscribe to my Lean University, which is my initiative to deliver free and quality professional education to your screen.
There are many new terms used in the design of experiments, and often these terms can be hard to memorize. Even professionals with years of experience have some difficulties in memorizing all these terms. In this lecture, we will throw away the traditional approach of memorizing the terms and instead try to understand the terms or the concepts using design of experiments in more practical manner. First of all, let's take our cannon example itself. Response. Here, in this experiment, we are trying to cover the optimum distance of the cannonball. This is cannon, where we can change the position of different factors and then fire the cannon. The distance traveled by the cannonball is called response. So what is response? It is the result that we want to achieve through the design of experiments, or simply it is the output of the process. The process is operating the cannon and the output of the process is the response. Response can be maximizing the profits, maximizing the yield of the product, minimizing the waste, minimizing the strength or weight exerted by a wheeling or a bridge, or maximizing the effect of a certain chemical, etc. These are just some of the few examples of the response. One thing to understand is response is the result of action of things that affect the response, which are called factors. So, response is the result of factors. So, what are factors? Factors are those independent variables that can affect the response or a process. Response is the result of action of things that affect the response called factors. In our cannon experiment, our response was the distance of the cannonball, but there are 4 factors that are responsible for the distance traveled by the cannonball, and these terms are called factors. For example, we have 4 factors: the pin elevation, because changing the position of the pin elevation affects the response or the distance traveled by the cannonball. Similarly, another factor is bungee position. Changing the bungee position also affects the distance traveled by the cannonball. The third factor is the cup elevation. Changing the cup elevation also affects the distance traveled by the cannonball. And another factor is the release angle. Changing the release angle also affects the distance traveled by the cannonball. So in this experiment, we have 4 factors: the pin elevation, bungee position, cup elevation, and the firing angle or the release angle. Making a change in factors affects the response we desire. We can change the factors as per our will in order to attain a particular response or a target. Though we took only physical factors in the experiment I showed, factors could be anything and may be related to manpower, method, materials, machine, or environment. Levels. We can set these factors at different positions in order to attain the result. For example, we could set the pin elevation from the highest 200 points or 200 units to the lowest 100 units. So we can set the pin elevation at different positions, and these positions are called the level. Here we are trying to operate on 2 levels, the highest and the lowest. Similarly, if we design the experiment keeping the position of the bungee position from highest to lowest, it also has the 2 levels. Similarly, we can also design the experiment at any levels of the factors. For example, I can also design the experiment at 4 levels. I can set the pin elevation at 200, 160, 130, and the lowest 100. If I do so, I will be operating this experiment in 4 levels. Note that when we change the levels of these factors, the response or the distance traveled by the cannonball also changes. For example, if I set the levels of different factors at the highest value, if I set the pin elevation at 200, the bungee position at 200, the cup elevation at 300, and the firing angle or the release angle at 185 degrees, then we will get the response. The response here is the distance travel. The distance travel is 466 units. If I fire again, keeping the factors at different level and fire the cannonball, then my response also changes. So the summary of this experiment is, when we change the factors to operate at different levels, we get different response. Remember that levels can be measurements and also can be attributes such as pass, fail, defects or non-defects, etc. Treatment. Treatment is a factor at a specified level. Treatment combination is a set of factors and their levels. When we are conducting the design of experiments, processes are run with factors set at a specified set of levels. Here, in this experiment, there are 5 factors: sand percentage, water volume, clay percentage, which are the controllable factors, and temperature of the furnace and time of heat treatment, which are the uncontrollable or noise factors. These factors ultimately affect the response, compressive strength of the brick. So the final compressive strength of the brick is the response, and these are the factors. Here we see that there are different levels for each of these factors, such as the percentage of sand may be 5, 20 or 35, water volume may be 5, 15 or 35, clay percentage can be 50, 70 or 90, temperature may be high or low. So the combination of the factor and the level, this combination is called treatment combination. So we have 5 treatment combinations here. 1 for the treatment combination of sand, 2 treatment combination of the water, 3 treatment combination of the clay, 4 treatment combination for temperature of the furnace, and 5 treatment combination for time of heat treatment. For simplicity, design of experiments are analyzed in this way: 2 times 2. Here, the lower number stands for the levels and the upper power number stands for the factors. So, if we have 2 factors running at 2 levels, we write it as 2 to the power 2. Let us see our Cannon experiment to understand this better. Suppose we are only looking for the cup elevation and the release angle. Suppose our bungee position and pin elevation is constant. While designing experiment, if we set our level at only 2 positions, that is highest and lowest of the cup elevation and the lowest and the highest of release angle, then we are operating on 2 factors and 2 levels. The factors are cup elevation and release angle, and the levels are highest and lowest values. So we analyze this experiment as 2 to the power 2 design. Similarly, if we represent as 2 to the power 4, the lower 2 stands for the number of levels and upper 4 stands for the number of factors. Similarly, the experimental design 4 to the power 3 stands for the lower 4 stands for the number of levels and the upper stands for the number of factors. Now let us understand what is run. When we set a process at a specified treatment combination, that is, specified factors set at specified levels, we run the process in order to collect the response data so that it may be analyzed later. The process is called experimental run. So, run is just the experiment. We may conduct different number of experiments in the design of experiments. Those experiments are called runs. Effect. Effect is what the factor does to the response. If the factor really affects the response, this factor is taken in consideration while designing the experiment. Effect can be measured in every other kinds of experiments as well. I have taken the Cannon example only in order to let you understand the design of experiments terms more easily. If you are a chemical engineer and you change the concentration of a certain chemical, say chemical X, and watch the pH value of the resulting mixture of the chemicals, then the resulting change in pH is your effect. We will learn about more advanced concepts like replication, interaction, randomization, blocking, etc. when we go through other lectures in mini tab. So, in this chapter, you learned about concepts like factors, levels, effects, treatment, response, and runs, etc.
Before ending this lecture, let me remind you to join my Lean University's premium membership and enjoy a total free access for limited time inside my Lean University's online library and get tons of free courses, free books, and lecture topics on project management, Lean and Six Sigma, operations and supply chain, productive and preventive maintenance, quality maintenance, data science, industry and sales management, agile and scrum, Kaizen or continuous improvement, and much more totally free. No strings attached. As we have limited seats, only the early subscribers will be given open access inside the premium membership, and remember, it's totally free. Please subscribe and share the video if you share the common belief that professional education should be accessible to all.